In this video, let's see the topic on mat foundation. First of all, myself B. Chellapriya, Assistant Professor Civil, Rohini College of Engineering, Palkulam. So first one is mat foundation. Mat foundation is also called as raft foundation. It is a provision of continuous thick slab on the soil that extend the entire footprint of the building. It is provided to increase the earth bearing capacity power, and this foundation support the whole building and transfer the load safely. The raft or mat foundation is used in most places where the soil have low bearing capacity. Next, use of mat foundation. The mat foundation is used when the bearing capacity of soil is weak and not capable to transfer the superstructure load to the ground, or the column is placed nearly a property lines, or deep foundation cost is higher. So in that time we are referring a mat foundation for making it economical. So type of mat or raft foundation. Following are the type of mat foundation. First one is flat plate raft. The second one is plate thickened under column, two-way slab and beam, piled mat, rigid frame raft, and cellular mat foundation. First one is flat plate raft. This flat plate raft is used in small and lightweight load structures, and this type of foundation is suitable where the soil is not compressible. Here the reinforcement bars are provided in both direction, tops and bottom, in the form of mesh. A minimum 6 mm thick inches of RCC slab is used in this foundation. Next one is thickened plate under column. So from the heading we can able to understand that the thickness of the slabs are to be increased for to it counter the upcoming load or weight. The flat plate before the flat plate foundation is not suitable for heavy structures, but the thickened plate columns is used to load carry for very high. Here, due to carry out of heavy load, diagonal shears are to be create, and also negative bending moment. So the thickness of the RCC slabs under the column should be thickened. Next, two-way slab and beam. In this type of mat foundation, the beams are placed in perpendicular direction and all beams are connected by an RCC slab, and the columns are placed at the intersection of the beam. Here, a two-way slab and beam raft foundation is suitable when the column carrying an unequal load and spacing is larger between them. So this type of foundation is to be used. Next one is Piledraft foundation. This foundation is supported by piles in the soil, and this type of foundation is suitable for the ground have high compressibility and water table is high. Mainly this type of foundation used for high-rise building, and piles were used to reduce the amount of soil settlement and increase the load bearing capacity. Next one is rigid frame raft. A rigid frame raft is used when the columns are having heavy load on them. In rigid frame mat, the basement of RCC wall acts as a deep beam or rib. Next one is cellular mat foundation. It is also called as box mat foundation. In cellular mat foundation, the structure of boxes are formed and walls of every boxes act as a beam, and the walls are connected by a slab at the top and bottom, and this type of foundation is suitable for loose soil. And advantages of mat foundation. So the foundation and ground floor slabs are pure simultaneously, which reduce our construction time and material, and it requires less excavation. It is provided where the shallow foundation is not possible and the condition of the soil is poor, and by provision is reduce the cost of the constructing of floor slab, but not economical. It helps in transferring of load over a wide area, and we can handle more heavily load as compared to other type of foundation. And disadvantage means the raft foundation require large quantity of steel and concrete, and this foundation is costly and it is not suitable for domestic home construction. In mat foundation, the skilled labors are required. Next one is floating foundation. Floating foundation is a type of foundation constructed by excavating of soil in such that the weight of the structure built on the soil is nearly equal to the excavate soil, total weight of excavate from the ground, including the weight of water before the construction of the structure. Next one is problem during in the design of a floating foundation. So during excavating of soil, there are problems that may be considered. First one is excavation, second one is dewatering, third one is critical depth, and fourth one is bottom height. So first one is excavation. So excavation of foundation due to has to be done with care, because the surrounding soils may be slide. So it is preferred to use that the side of the excavation should be suitably supported by a sheet pile wall. Next one is dewatering. So before excavating the soil, it is better to examine the water table level in the excavation pit. If the excavation is below the water table, then dewatering is essential. Next one is critical depth. If the shear strength of the soil is low and there is no limit to the depth of excavation can be made. So Terrazai already did the computing for critical depth. That is DC equal to 5.7S divided by gamma minus S by B root 2. Here DC is a critical depth, S is a shear strength, gamma is a unit weight of soil, and B is a width of foundation, and L is a length of the foundation. And symptoms also propose the equation for DC, that is critical depth, and which is based upon the actual failure in excavation, that is DC equal to NC into S divided by gamma. By using the above either Terrazai or symptoms, the critical depth of excavation can be determined. Next one is bottom heavies. Bottom heavies, when the soil is excavated to some depth, the pressure on the soil below this depth is lowered, which results the formation of heave. So due to formation of heave, it leads to cause a settlement of the structure or foundation. So the formation of the method, we want to make some method to minimize the formation of heavies. There are two possible causes of heavy. First one is plastic inward movement of surrounding soil or elastic movement of the soil in a existing overburden pressure. So next one, advantage of floating foundation. So first one is load bearing capacity soil. So the floating foundations are best in area having a low bearing capacity soil or building over the loose soils or soil with low compressibility, that is various degree of compressibility. Next, nearby buildings. If a floating foundation is poured over the building foundation or close or deep foundations which may interfere with the existing buildings. Next one is moisture. Moisture means floating foundation can be used on high moisture soil, because the position of foundation above the earth rather than it helps create a moisture barrier between the ground and the structure. Next one, trenches. Floating foundation requires a less digging of soil excavation. Movement. If the earth are expected to move towards the underground moisture or to high level, it can be minimized by a provision of floating foundations. Next, in this video, we have seen about types of mat foundation and its types and its floating foundations. So, thank you.